We're Team Beta from Preaching Middle School in Macau.
Although we are not in the same grade in our school, we are friends and teammates as we are working on our project.
Let's go in depth to our research journey.
After studying biology and chemistry, our teacher talked about a byproduct respiration, which is ROS. We started researching ROS and were shocked that it's actually hostile to antioxidants. And what's more devastating, it is a major factor that causes the production of cancer.
Since 2018 March, we spent all of our resting time reading journals, and we came up with our preliminary idea of using medicine to target cancerous cells by its high ROS release characteristic, as well as to decrease the side effect of the therapy as low as possible. Fortunately, we got the opportunity given by Professor Raving Wang from UMac and the program of FDCT, and our school have sponsored us throughout our whole journey to work and experience the life of a biochemist.
After our in-group discussion, we decided to modify the efficiency of our particle before doing in vivo study. Hence, we redesigned our project and created a new one. The new project has better capabilities in every aspect than our previous project.
ADA was dissolved in 100 ml of anhydrous DCM. Then, DMAP, EDC, and BA were added to the above solution. After 15 minutes of stirring, a yellowish liquid was formed. The yellowish solution was stirred at room temperature for another 2 hours. Rotary evaporation was then performed to remove DCM, transforming the yellowish solution into a white powder, BA-ADA molecule. The crude product was purified by chromatography on a silica column using a mixed eluent of petroleum ether and ethyl acetate, acquiring the compound required as a purified solution, with which rotary evaporation was performed again to collect the pure BA-ADA molecule. CB7PLA SSPLA nanoparticles were prepared according to oil-water emulsion method with an ultrasonic cell crusher. CB7PLA and SSPLA were dissolved in DMSO. 1% of PDA was subsequently added. Lastly, 2M concentration of PTX was added. To separate DMSO from the particles, centrifugation method was used with a speed of 4,000 RPM for 5 minutes. The large-sized particles were discarded. Subsequently, high-speed centrifugation of 14,000 RPM was performed. By removing the supernatant liquid, malformed particles were discarded. To weigh the particle, we weigh the solution carrying the nanoparticles. Subsequently, we divide the solution with the volume of the nanoparticles. The calculated weight is the weight of the nanoparticles. According to the Tyndall effect, as shown, pure water doesn't show a light path.
Cell culture is an important character for cell studies. The cells that we have used are raw, 41, A12, LO2. Cells grow in a culturing bottle full of DMEM inside an incubator, 37 degrees Celsius and 5% carbon dioxide. The cells will undergo mitosis and grow. When the cells proliferate to a certain density, it is necessary to isolate a part of the cells and inoculate them into new containers. The aim of the MTT assay is to examine the cell viability rate. We prepare a 96-well plate with 6,000 to 8,000 cells per well. After 24 hours, we replace the drug solution with DSOL blue for 3 hours. Then, the DMSO is added. After that, we deploy it into the microplate reader and test the intensity of 430, 460, 490 nanometer wavelength absorption to calculate the cell viability of each group. Flow cytometry analysis was performed to evaluate the cellular uptake of both single and dual responsive nanoparticles. They are loaded with CY5.5 as a fluorescent cargo. As a cell in this experiment is suspended, we first decant cells from 6 well plates to centrifuge tubes and centrifuge them. Then, discard the supernatant and resuspend pellet in PBS and repeat the previous step. Lastly, discard supernatant and resuspend in a suitable volume of cold staining buffer. After the preparation of samples, we rinse the interior of the machine by flowing water in for half an hour. The sample cells that have uptaken the particles will be sucked up into the machine with a series of optical systems that excite the fluorescent and generate a photocurrent to the detector to digitize a series of results and form analytical graphs. It's a journey, an adventure, and a personal growth challenge like nothing you've ever experienced. I would be lying if I said it was all sunshine and roses. We have cried and we have celebrated.